So this is number 55 on page 356. It looks like a square, but we're going to go on how to actually prove that it is a square. And so what I'm going to want you guys to do is go ahead and I'm going to draw these. What am I drawing here? Diagonals. Okay, and that's what we're going to use to prove this is a square. Because, of course, a proof, we would have to do more things. Because it's hard to look at this and go, is that a 90-degree angle? Or is that an 89.9999 degree angle, right? So probably on graph paper it doesn't matter, but in real life you really want your stuff to be correct. So we're going to actually prove it. And so the first thing we need to do is I need to find the distance. And actually there's several ways to do this, but the way I want you to do it is I want you to find the distance between J, L, and the distance between M, K. Okay? And if you don't remember the distance formula, remember the distance formula is, I'm going to get rid of this real quick. Distance formula is square root of everything, x2 minus x1 squared plus y2 minus y1. Okay, so go ahead and do that. And what points am I going to use? Well, some people label it like I did. Some people, just to make their lives easier, will go like this, negative 4, 2. That way they don't have to look back in the book. 0, 3, 1, negative 1. And M is going to be negative 3, 2. Is it negative 2? Yeah. Okay, good. I was going to get it wrong. Okay, so what numbers do I need to put in here to get the answer? And again, it's all calculator, right? Okay, that L looks ugly. Sometimes run out of ink. So let's see, we're doing JL, right? JL. So I could do for X's, I could do 1 minus a negative 4 squared. And then I could add that to what?
2 minus negative 1.
It doesn't actually matter which order. I'm going to stick with the same order I did it in. So I'll do. It doesn't actually matter. This is a very, very forgiving formula. As long as the x's are together and the y's are together, it doesn't really matter what order. Okay, but we do need to put this down. And the calculator, make sure you put it down correctly in the calculator. If you don't do it correctly, guess what? You get the wrong answer. That's the nature of calculators. So just make sure that you do it correctly. And so I just go ahead and put the parentheses just in case. There are ways to do it without parentheses, but I'd just do it exactly the way I wrote it. I didn't do it that time. There we go. Oops. Well, unfortunately, sometimes you start over. Okay, it's all under the bar, right? Wow. So this one's having some battery issues, I think. So that's great. So what did we get on this thing? And if you got some kind of error, you got to be careful about, that's a negative sign and that's a minus sign. So it looks to me like I'm going to get, and that's fine. That's the answer. So I'm going to write equals radical 34. That is the exact distance. Okay, now we want to do MK. We're going to do the same thing for MK. Okay. And what am I expecting? If we think this is a square, what are the diagonals going to be on a square? Are they going to be equal?
Yes.
Because a rectangle is equal. Okay, so let's go ahead and do that. Put it in. Let's see if it's the same. All right, so here we go. Let's see here. It is, well, doesn't matter which one's first, does it? So I'm going to do negative 3 minus 0 squared plus negative 2 minus, I think, 3 squared. And that's interesting. I bet you no one sees that. All right, and so we put in the calculator, and what are we going to get? Radical 34 again, right? So that's the same. So here's where the proof part comes in. Okay, so looking at our rules, and we have them written down in our notes already, we're going to look at this theorem right here. The rectangle diagonal theorem, and I'm going to have to focus because we moved the camera angle. A parallelogram is a rectangle if and only if that its diagonals are congruent. Okay. So what I'm going to write is a statement. I'm going to write the statement that, what is this shape? J, K, L, M is a rectangle and in all proofs we have to have a reason. What's the reason? The rectangle diagonal theorem. Okay, are we going to use this on every shape that we do in this section? This exact order? Yes. Because we need to either rule out that it's a rectangle or prove that it's a rectangle to determine what kind of shape it is. Yes?
So it says to prove all of them, will we have to do this for a bunch of different things?
We're going to, well, it says to prove, if I'm, are you talking? It says, decide whether this shape is a rectangle, rhombus, or square. Give all the names that apply. Explain your reasoning. So this is my reasoning right here, right? And so I'm not done because I think this is a square. And so you're going to have to do this for all of them, every single last one of them, to prove whether it's a rectangle or not. Okay? Because disproving sometimes is as important as proving. Okay, and so what do we need to do next? What is the other thing that we can do? I want to prove that this is a rhombus, right? So what do diagonals on a rhombus do? They form a, they're perpendicular. So now I want to do the slope of the diagonals. So go ahead and do the slope formula. This takes some room. So we do the slope of JL. This pen is not doing well for me. And then so let me make sure we do this one right. JL would be, the Y would be negative 1 minus 2, and the X would be 1 plus 4. And I think we're going to get a what? And this one should be, yeah. This one should be, okay. So, but they're not the same, so it doesn't work, does it? What is it? I forgot. What is perpendicular?
The slopes are opposite reciprocal.
They're the negative reciprocal of each other, right? Okay, so if they're the negative reciprocal of each other, then, I'll mark that out, not confuse people. If they're the negative reciprocal of each other, then that means that JKLM is a, what is it? A rhombus? Okay, so a rhombus. And let's see why. Let's see. Okay, the rhombus diagonal theorem states a parallelogram is a rhombus if and only if its diagonals are perpendicular. Okay, so JKL is a rhombus because of the rhombus diagonal. And yes, theorem. And I need to refocus because I showed you the theorem. Okay. So I've proven it's a rectangle. I've proven it's a rhombus. We don't have to do any more math, but we do have to do this last little bit, which is the square corollary. Okay. Square corollary states, a quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay? So how do I need to include this? I need to include that JKLM is a square, and because of the square corollary. Coro. Okay. JKLM is a square because of the square corollary. Okay, so now I've proved it's a square. I proved it's a rectangle, then I proved it's a rhombus, then I proved it's a square. That is what you're going to do on all these problems. What I recommend is you do all this on a separate sheet of paper and you just do the graphing on the graph paper. Okay, how many problems are we going to have to do of this?